Okay, thanks for coming in and hearing my talk. So, as a startup company, my presentation is not about my company, but if you want to read more about it, you could go here. Still a bit in stealth mode, but you can keep sign up for my mailing list there. I'll tell you more about it going on. If you need to contact me, you can also drop me an email at chc2017@Sandfly Security as well. I'll answer you, or obviously I'll be here all weekend. Just come up and grab me. It's not a problem at all. As Kim mentioned, my background is really in intrusion detection systems, intrusion prevention systems. I got started at a small company in San Antonio, Texas called WheelGroup Corporation. It was started by a bunch of guys at the Air Force Information Warfare Center. We produced probably the first commercially successful intrusion detection system called NetRanger. We also wrote a security scanning product called NetSonar. I wrote the network attack libraries that were used in that product, and we were bought by Cisco Systems. We ended up moving up to Austin, Texas, where I started another company called Psionic Software that did a real-time incident response system. So when an intrusion detection system sees an alarm, our system would then connect to the host to see whether or not it was compromised, and then it would tell you whether or not the alarm was good or bad based on that information. And finally, I also did work for another company called TippingPoint Technologies. We produce a multi-gigabit speed inline intrusion prevention system. So that's kind of my background. I've always gravitated towards the white hat side of things. And in the process of working on this latest company here, I discovered that there's a lot of basic things you can do to detect attacks on Linux systems, and a lot of people really get confused about what your priorities are. And today, this presentation is really about having you focus priorities on the basics of looking at your hosts in terms of what kind of stands out without really relying on all the marketing fluff around advanced persistent attacks and things like that. So what you're going to learn today is checking Linux systems for suspicious activity using basic tools. And when I mean basic, I mean stuff that's already loaded on the box. I'm not talking about a specially designed forensics kit or anything like that. I'm just talking about basic commands. We're not going to learn anything about zero-day exploits, advanced persistent threats, or any sort of stuff that the marketers are trying to sell you, because by and large, I find if you can't find the basic stuff, looking out for what the creams are doing. The first thing we're going to start is what I call the 1001 rule. What this is, as we all know in the computer security world, that defenders need to know thousands of ways to prevent people from getting on the host, but attackers only need to know one way to get in, okay? 1001. So it's really, really stacked against you in terms of doing defense. That's why hackers have such good success rates, because they need to just find one way to get in. But what a lot of people don't realize is the flip side of this, which is once the person gets into the host, they need to know about thousands of ways to cover their tracks, and we need to spot them once. And that's what a lot of people don't really recognize in terms of spotting attackers that have compromised the system. It's very, very, very hard to get onto a host and not leave signs that you were there. Even if you got on with the most elite attack available, you paid millions of dollars for off the black market, once you get onto the host, you're in my world. You're in your world. If you're the admin, you know the systems better than the attackers do. So that's what we're going to be covering today. Firstly, I want you to think about simple first. And this was a saying that a general surgeon said, that common problems are surprisingly common. And this is kind of in response to people who they feel like some upset chest and they go into Google and a half hour later they diagnose themselves as having stage 4 pancreatic cancer. But really, they just ate beer and pizza, they have indigestion, right? So always look at the common first. It's kind of like Occam's razor, right? Let's not jump to conclusions. So don't worry about advanced persistent threats. I want you to worry about, this is my acronym for today, commonly run attacks preferred, or CRAP, okay? You don't worry about advanced stuff, because if you can't spot the common things, why are you worrying about all these other advanced things going on? Okay, so that's going to be the general theme we're running with here. Now, just to beat this dead horse one more time about zero-day attacks. What about them? Right? Again, marketing, they push the stuff down your throat. Zero-day attacks are relatively rare and really expensive. I haven't looked at the market in a while, but last I checked, I think an iOS zero-day attack that was really effective to compromise the host, was it something like $500,000 to $1 million, something like that? I forgot what it is. It's a really high number. So talk about bug crowd, right? If you could sell these types of attacks to various agencies, you can make a lot of money. So they're not common. The common attacks that are out there, they work. And in terms of, let's say, a nation-state actor, they have total deniability, right? Anyone could run the attack. They're all over the place. Okay, the other thing with these advanced attacks is that they're usually very particular about how and where they work, right? They're going to be a very specific version of kernel operating system. There may be very specific versions of software that you have loaded on the box. And a lot of times, if things aren't exactly, the stars aren't in perfect alignment, you can wreck the box or break the box. So that's why in today's presentation, I'm not really going to be covering stealth rootkits, because a lot of times they kind of fall into this category where they look really cool, but once you run them and you try to install them, you're going to run into these problems of wrecking the system, breaking the box, causing all these things going on. And again, it gets back down to what I call a 1001 rule, that even if they get onto the box with that really advanced attack, they still got to bring all their goodies along with them, and they got to hide the fact that they were there, and that's really, really hard. So the basic concepts we're going to work with. Number one, computers are not spontaneous. If it was working fine, and then all of a sudden at 3 a.m., it's not working fine, we should take a look. Which leads to the second point, and we're going to focus first on what got our attention. If the web server crashed, it's never crashed before, or the print server crashed, never crashed before, that's probably where the action is going to be. Now, when we're talking in terms of the actual ways hackers are going to get on the system and remain there, they're all trying to do three things. One, they're going to set up a directory, usually to hide the goodies. Two, they're going to have suspicious files. These can either be files that they modified or files that they brought along with their kit in order to spread laterally through the network. And finally, they might start up some suspicious processes on there for botnets and things like that. So these are really the three things. We're going to focus all of our effort looking into directories, files, and processes using common tactics. Okay? Any questions so far? No? All right, pretty straightforward. So the basic commands are going to run through again. These are virtually loaded on every Linux operating system you're going to find out there. You'll notice that for reasons in this talk, we're not going to do anything special or unique. This is really made for the kind of thing where you're called to look into a host and you want to quickly take a gander around to see if there's something more that needs to be taken advantage of. Kind of like fast forensics type deal. First thing here is always the suspicious directories. When I'm looking at various products and rootkits and exploits and other things going on, a general trend you will see over and over and over again. These tools tend to target various directories that are common on the system. The temp directories, dev SHM, which is a shared memory volatile directory. They tend to throw things in the bin directories. The lib directories are also important. And finally, a couple things here. var log, they're almost always going to go on there. It's like a moth to a flame. They got to go mess with the logs. And finally, web server directories, privileged directories, stuff like that, tend to be lower on the list. But I find the default rootkits, the default compromise tactics, the default automated attack scripts are trying to hit these standard system directories first. So when you're starting to take a look on a system to see if there's a problem, kind of start in these areas. That's probably where you're going to find the most situations that are going to stand out. Suspicious directories, they take pretty basic forms. Again, this isn't rocket science here. They're going to try to look like an ordinary system directory. They're going to be scattered in a directory that's a system area that's always going to be present on every host. So for instance, if you're writing an automated attack script, you don't want to have to customize it all the time. You're only going to use directories that you know are going to be present on every version of Linux that you're going to possibly be on. Okay? And a lot of times these scripts, if you ever watch on a honeypot, they're being run by people who aren't that technically savvy sometimes. You know, you see them making a lot of mistakes when they're typing and things like that. So they want stuff that's very easy to run, and it's going to be something that it's going to run reliably. And the only way they can do that is use standard system directories. You're going to see a lot of weird permissions, attributes, and creation times. One thing here, too, is it's not going to match what a duplicate virtual OS image shows. And I'm not going to talk too much about that right now, but one of the benefits we get to today is if you're looking onto a CentOS 7 box, run an image on your local machine. If you ever have a question, just look at the virtual image, and you know immediately that there's a problem. So it's a very handy tool to keep VirtualBox loaded around with the basic installs there. It's way easier than you think about 10 years ago. I mean, you had to have a full image set up. You'd have to boot the machine, all this stuff. It was a real hassle. Today, it's very, very easy to have a virtual image of the operating system right next to you. You can always go back to and refer if you think that there's a problem. And finally, these directories are always going to find suspicious files and data, which we're going to touch on. So here's an example of a system that has some problems. In a Linux host, you're typically going to get dot and dot dot at the top of the directory. But you see here, this one has a whole bunch of problems. It has something here dot, another one dot space dot, dot, another one looks like dot, question, dot with a special character, on and on and on. Very, very common, you're going to see directories like this with a lot of the prepackaged rootkits, a lot of prepackaged install scripts for various tools that are out there. One quick way in order to make more sense of this is instead of using ls-al, you can just throw p on the end. So ls-alp, it will throw a handy slash behind a space or white space characters in the directory listing. So now you get a better idea what's going on. So this directory at the top is just called space. Here's one called space dot. Dot space, dot dot space. Here's one dot dot dot, try and look legit, on and on and on. But if you're not careful, this is why I say careful attention to detail. If you did a directory listing, you could have dot space, it'll just fly right up. And typically, because a lot of these rootkits are not trying to hide the directories by doing kernel level obfuscation, it's something that you might miss if you're not being careful, but it's something that if you know what to look for, if you always look at the top of that directory, see anything at the top that's standing out, looks kind of weird, this is a really good place, this is a really good command you can use to start kind of looking into what's going on. Other things that you're going to find, let's say you did find some suspicious directories in a particular area. One of the next things you're going to find are some of the kits that are out there, especially some of the worms, are starting to use immutable flags in order to maintain persistence on a host. The immutable flag is set. What that means is essentially you cannot delete that file with normal system commands. It's what's called an extended file system attribute. So you actually have to remove the immutable flag from the file and then run RM on it. But this is a way that some of these worms are going around and maintaining their ability to stay on that system even between reboots. You can use a command on Linux called lsadder, and this is basically the ls command, but show me all the attributes, extended attributes. Anything with an immutable flag, it'll just show up as an I. Okay, so here we have an immutable flag set on a directory called dot dot dot. I would definitely want to look at that. An immutable flag down here on bin.foobar again. Anything like that is really odd. It's not typical of Linux to go setting immutable flags on things like this. So again, if you're looking at these system level directories, you're starting to see immutable flag set, you're starting to see weird file attributes, even some of these other attributes could be suspicious depending on the situation. You probably want to take a look at it. Okay, next up, usually when you start finding these directories, you're going to start finding suspicious files to go along with them. And what do I mean suspicious files? Well, it could be a lot of things. Usually it's going to be missing or tampered audit log files. It's very common. Files that are not the type that they purport to be, and I'll tell you what I mean about that. And finally, you're going to find binaries that are modified or in strange locations. And this isn't a reverse engineering course, so I will show you some basics behind some of that, but we're not really going to get into reverse engineering it. But the main things you're going to want to see is you're going to see these top two things pretty commonly in systems that get broken into, just in terms of people trying to cover their tracks, and then again, trying to hide what they're doing once they're on the system. The audit logs are an extremely high value target, and you're thinking, yeah, it's obvious, right? And it is obvious, but it's also something a lot of people don't really pay attention to. As a system admin, it might not be a bad idea just casually, if you're logging into a host, just take a look in the var log directory, just really quickly, just make sure everything looks right, right? Even if you don't think there's anything wrong with the system, just take a peek. It's just a kind of a good habit to get into. It's almost just like checking the oil on your car every now and then to make sure it's not getting low. This directory is hit so often and so sloppily that a lot of compromised systems are found just by taking a quick look through here. The big files are going to be the wtemp. This is going to show all your valid past logins. Last log, this is a special file that's going to show the last login for all the users on the host. btemp, which is something a lot of people don't necessarily know about. This shows all the bad login attempts. utemp shows all the current logins, and of course, various logs under the log directory. These are all very, very hot items for an attacker to want to get into. In this case here, I ran a log cleaner to remove an IP string from my logs, and some of these tools are not very well written. This one did such a good job cleaning my logs that it made all of them 0 bytes long, okay? Again, very common. In fact, some of them are quite deliberate about it. Some of the worms that went out just will simply touch all the logs, make them 0 bytes, and that's it. They don't make any temp whatsoever to clean the logs because they know a lot of admins don't look. But here's some perfect example of a syslog of a log cleaner gone bad. 0 byte audit logs, always suspicious. Here's a btemp file, shows no bad logins. I don't know, if you're on the internet and you don't have any bad logins, something's wrong, right? You're probably getting something. No kernel messages. Again, kernel log's empty, right? You don't reboot the system. You never had a kernel error. It's very odd. Here's log rotate. It rotated a 0-byte file. And again, this is an example of showing everything that could go wrong, but any one of these things by itself, to me, could show a particular problem. And finally here, the date and the time are all identical, right? October 25th at 00:55. That would be a really good time to look on your system, right? Just to see if someone's been around at about 55 minutes after midnight. That's a really good time to start looking. But this is an example, again, of just one log cleaner that's screwed up. But any one of these things, I've seen various mixes, iterations that show this same type of situation going on here. Very poor log cleaning or making no attempt at all to clean things up. But this is a surefire indicator that there's something going on in this box that you need to look into. Now, after I find, for instance, that maybe the log directory looks a little odd, one of the next things I like doing is just taking a quick look at the temp directory. The temp directory, because again, it's on every Linux host on the planet, it's very often used as a scratch pad for a lot of these attack tools. They'll write temporary files in there, they'll move things around, they might keep dropper data in there, and on and on and on. But also, sometimes these tools fail. Again, people bring the files over, maybe pre-compiled, or they compile them on the box, they're not quite right, something happens. In this case here, I look in the temp directory and I see a file called utemp.back. It's odd, right? You know, this is pretty straightforward stuff, but I've seen log cleaners leave things behind. I've seen system binaries left in here that have been renamed, for instance, a shell named .s or .t or .whatever. I mean, why did someone have a shell? Why is there a shell in the temp directory? Why is there any command in the temp directory, for that matter? So you'll see this kind of thing a lot. So this file was left by a poorly written log cleaner that crashed. At this point, I now can say, again, maybe I have a good time to start. September 5th, 12 minutes after midnight would be a good time to start looking around on this system for any other particular files that might have shown up. The other thing here, now I've seen that utemp file. I said, okay, well, it's probably game on. Someone's probably run a log cleaner on my system. What can I do with common system tools to start seeing if there's any other problems? There's a really good one on Linux, utemp dump, UTMP dump. What's cool about this utility is it just gives you a raw line-by-line dump of the wtemp, btemp, and utemp files, where if you run a command like last or w or who or whatever, they try to format it to make it look pretty, and if something's been nulled out, they just won't show it to you, right? So if you're running some of the older log cleaners will just take an entry and just overwrite it with zeros. It's very common. About half the log cleaners do this. The better ones will actually delete the entry and then patch the file back together correctly, but a lot of them don't. So again, a attacker, they go to whatever site it is, they download log cleaner, hey, it compiled, it worked great, and they run it on the host. Well, if you just run W, you're not gonna be able to see some things, but with utemp dump, I can start seeing some interesting things here. First of all, this first column is showing the type of entry it is. So for instance, type 2 is a reboot, this is a restart. Here are some logins, type 6 and 7s. 7's another login, type 8 is like a log out if I remember. But then I get a type 0. Type 0 is invalid. And then it's, again, for the process ID, it's all zeros. These are all blank, 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 0, 0, 0, 0. Another date, all blank, because someone overwrote it. And again, this is the type of thing that wouldn't necessarily show up with the standard tools, but utemp dump is more than happy to show that someone has come in here and overwrote that entry with a bunch of nulls. Kind of taking it one step further, using the same command against the btemp file. I talked earlier how btemp is used for showing bad login attempts. These are the attempts that should not have worked. And you're going to get these all the time. You can see CBM logged in, all these scripts. I mean, if you're on the internet for 2 seconds, you're going to get hit with this type of stuff. But then all of a sudden, I start getting a bunch of this. So someone went through, and what that tells me is they picked a username they didn't want me to see that they logged in with, whatever it was, maybe some default user. Here, it wasn't CBM, but it was something else, and they decided to write over everything. So the utemp dump command, again, shows this, and the other commands on the system may or maybe not. It might depend on the version. But utemp dump works on the wtemp, btemp, and utemp files to kind of show some of these things going on. And kind of to show a comparison, there's a command called last, which shows last login, the last logins of all the users. There's also last B, which shows all the bad logins. So this is the same file here. And in this case here, this one actually did show a couple entries that are suspicious, but maybe not quite as much detail as before. I see January 1st, 00000. Again, someone blasted it. You can kind of see the difference of what it shows. This is what utemp dump would show. You could see it's trying to show me IP address, all these things. The last B command just misses some things there. So it kind of shows the same thing, but again, you need to really be paying attention to make sure you're going to notice it if you actually need to run this command. Other things to look into, just generically to find suspicious files. On Linux, with the Red Hat and Debian variants, it's very easy to find files that have been modified away from the base configuration. On Red Hat, there's a simple RPM command, -VA. You grep it through this here. It's going to show you all the system files that were modified from the basic ones. And here, in this case, SSH and a bash RC have been changed from standard install. I would probably want to go inspect those to make sure something wasn't maliciously done, especially when you see any type of shell logins and things like shell login scripts and stuff. You want to make sure there's nothing in there malicious. Under Debian, they have a command called debsums, which is often not loaded by default, but I recommend you do load it on your systems. It's about 500K. It's really pretty small. And here you can run it with a -C command, and it'll show, again, all the system binaries that are different from the system install time. In this case here on this system, user sbin note login is altered. Does anyone know why that might be important? Anyone? Come on, speak up. That's right. What happened here is this was replaced with a bash login shell. So when you're looking through etc password, it looks like they can't log in, but they can. So just kind of, again, simple thing, just an attention to detail. This can help you spot a lot of potential problems on the system. Okay, any questions so far? I know I'm rolling through fast, and this could be the kind of thing where I can make it a full day training. Anyone have any particular questions or anything mid-break? Yes?
Is TippingPoint going to find, the YouTube you showed, going to find packages that are modified even if you install them properly? Right.
That's a good question. I don't know. I'd have to run it to see. I'd have to run it to see what it would do. There's too many variants. It's one of these things where each package installer, it should be, right? It should look okay, but I don't know. Yes?
Log files and var log used to be simple.
Yeah.
Now there's system data and general control and things just go.
Yeah, they can, and some of the log files are kind of in a weird format. So like the last log file is a sparse file format, which is, it looks a little weird. Yeah, it could be some more binary files now. There's still a lot of text-based on Linux. Almost always I'll find that there'll be enough text there that they shouldn't be missing at a minimum, right? 0 bytes, stuff like that. I'm going to want to take a close look at the thing. I'm sorry? Are they? Yeah. Are they? Okay. Yeah, I don't have enough experience there to tell you one way or another. Most of my experience is just standard Linux to see what's going on. Yeah, in terms of there are some log files you're definitely going to need some type of file utilities. I was writing some libraries to go through to do a lot of system auditing. I had to write a lot of custom files to parse out some of the system log files and stuff to pull information out, like you said, for that reason. Okay, last thing here, they're going to probably try to run some type of suspicious process on the host. And what I see here, it just depends on what the attacker's trying to do. A lot of the automated scripts are trying to set up botnets. They're trying to set up ways to get back on the host through bind shells and other backdoors. They might be trying to set up some type of file server as well. What you see usually are processes that are trying to look legitimate. There can be open ports you don't recognize, Or then you're going to get the really bad stuff, like deleted processes or deleted processes with open network ports. These are almost always an indicator that there's going to be a problem. The problem is the way Linux is set up by default, it might not be immediately obvious that it's a deleted process still running. I want to show you in a second here what you can do to spot it. But to give you an example of a suspicious process, just running a simple netstack command with the NALP, this will give you a full listing of all the ports that are open, the local address it's listening on, and it's also going to show you the PID and what the process is calling itself. Here I have something called Apache, which Apache doesn't call itself Apache, running to port 2222, and it's doing a couple really odd things. First of all, it's got this TCP port open, which you're like, okay, well, that's odd. But then it's got a raw socket open. And here I could see here, I won't get into too much details. I could see it's ICMP protocol. Again, I could see the Apache process is running not only a raw socket, but a TCP socket. I wrote an older tool for Linux systems years ago called Port Sentry, which used raw sockets to do network security monitoring for packets. But it's very unusual for most system processes to want to open a raw socket. It's usually someone running a password sniffer or network sniffer or some type of grabbing raw packets in. But here it's really strange because this process had both. It had a raw socket and TCP open. And this is kind of interesting because what this might actually be is an ICMP port knock backdoor. And what that is, it's a special bind shell backdoor where it just listens on a raw socket for ICMP packets to come in. When a special packet comes in with certain header values set, it will then open up a TCP port that you tell it to in that ICMP packet. So it's kind of a stealth backdoor. So that's why I ended up seeing two of these things here at once. Someone ran the sniffer, it's on an open socket, raw socket, and then they send it a packet later to say, open up on port 2222 and put your bind shell there. So that's why you might see something like it. But even then, even ignoring the TCP, if you see anything with a raw socket open on the box, I'd be a little bit wary of what it is, unless you know specifically with some type of security monitoring software or some type of network monitoring software that you know should be running on that box. Otherwise, pretty odd thing, I would say. Now we're going to dig into a little bit more here. So we see this Apache process. Okay, well, let's find out a little bit more. Standard PS command, PS AUXWF. This is going to give us a wide format. It's also going to do this neat kind of threaded thing here so we can kind of see what process, child processes are associated with it. It's also going to give us a full path to that process. And we're going to see a couple things here that are going to stand out. One, a high process ID. This is really odd for any system daemon that you expect to start up when the system starts. Okay, you can see I left some of these here before I concatenated this a bit, but you can see 2, 3, 4, 5, 7, 667, 700. These are things that start pretty early in the process. 22.251, that started really, really late. So someone started that process well after the system had started. This doesn't work on every OS. Like OpenBSD, the process IDs are completely randomized, but Linux doesn't do that, okay? The other second thing here that I would say is very, very odd. Remember how I said there's certain directories that the attackers tend to go after, and dev is one of them. It's pretty high up. Well, this is running out of dev, this particular process. That's really strange, really strange. You know, if you don't get a system daemon that's running out of like typically the home directory of the user it's associated with or things like that, it's pretty odd. You should look into it. You know, so again, you see anything running out of dev, anything running out of temp, anything running out of a root directory, even the root home directory, I'd say anything running out of there would be pretty suspicious. These are kind of things that you want to look for. And again, it's all about just kind of paying attention to what looks a little bit out of place. So I know this process already has a ton of problems with it. Going back one slide, here it's got 2 ports open, one a TCP port, which is a very bizarre 2222. No, what is that? Doesn't mean anything. It's got a raw socket open. It's calling itself Apache, which is strange because Apache doesn't call itself that. And then going further, I see the high PID again, and it's running out of dev. So let's take one final look at this particular process ID. There is a special directory under Linux called proc. This basically contains all the process information that the Linux kernel uses in order to show you neat information such as the ports are open, file descriptors it's using, executable location, It's huge. You should take a look at it one time. But what's really neat about this directory is it's really not something that can be easily modified, even as a root. If you go in here to this directory and you try to make directories or try to add files to it or things like that, you're not going to be allowed. It's not going to let you do it, even as root. There are ways you could do it. I've seen some people have some techniques to kind of bypass it, but you stand a chance of breaking the box. But what's interesting about the proc directory is I can do ls-al proc and then this process ID, and it's going to show me a huge range of things that it knows about, the kernel knows about this process. And the most interesting one is the exe path. And this says dev Apache, which I know, and then it says deleted. Linux is very nice because it tells you when something's been deleted off the disk. And that's what's happened here. Again, this isn't something PS would show you. This is something that you would have to kind of trace back through the system. There might be a PS flag. I don't remember ever seeing one. But at this point here, this processes everything we don't want to see in something running on a box. It's got a weird name. It's got ports open. It's got a high process ID. It's running from the dev directory. And oh, by the way, they deleted it from the dev directory after they started it. This is all the classic signs of a worm, malware, or some type of automated attack script. And the reason why they delete it is really quite simple. First of all, it works, right? Now I can't go find this binary quickly to reverse engineer it and see what's going on, right? I'd have to do something to get it out of memory with some type of memory imaging or something like that. Second of all, if you're running any type of change monitoring or hash change detection on the system, it's not on the file, it's not on the disk anymore. So you're running this thing once a day, it's not going to see that there is a new file added to dev because it's not there. So it's simple, but it works. That's why they do it. Now, the last thing I'll talk about a bit is to really get into the suspicious processes. If they haven't deleted it from the disk, really basically, you don't need to be a reverse engineer to take a look at something that's on a disk that looks odd. And I would just say use the strings command. Strings command is basically like the cat command, but it doesn't show you any binary characters. In this case here, I run the strings command on suspicious binary, and I can see certain things here. I call it the holy trinity of bind shells. Listen, bind, accept. I see these system calls sitting here. This almost says that there's something that's a network server of some type, and then I can see at the bottom, it's calling out the bin shell, which is pretty much the death knell for this thing, that it's up to no good. And you can use this for other things as well. Even if it's not a network server, you can run this command on other malicious binaries that are, for instance, trying to hide, use hidden directories or things like that. So I've used this on one binary that I saw as part of a stealth rootkit, and it immediately showed me the hidden directory it was using to store all its goodies in, because it showed up something weird, /dev.random character string. Well, why does the binary have that embedded in it? So this is kind of a quick way, even if you're not a very technical person, just to quickly look through and see what's going on. You might also find other strings in there that could be passwords, strings that could be IP addresses that it's connecting back out to, which could be really helpful if you need to detect that type of traffic on your network going forward. And it might also show you other files that it might be trying to read or get access to, even if they're not on your system. Again, if it's an automated script, it could kind of show you what the game plan's going to be, what that thing's looking for down there. And I kind of have here a warning of not to run strace on suspicious binaries. And strace is basically a debugging tool that will run through the process and show you everything that it's doing. And so, does anyone know why you might not want to run strace on a binary on a production system? Sorry? It's executing it. That's right. So, I mean, it would be fine if you copy this over to a system you don't care about, a virtual image somewhere in the cloud that you're not connected to. But if you go into the temp directory and you're like, what's this weird file? I'm just going to run strace on it. Boom. You don't know what it's going to do. In fact, I thought it might be funny specifically to make a program that detects strace or debugger being used and just throw it on the system and let it wait for someone to run strace against it and then use that person's credentials to start plundering things. Kind of like a bait. I think that would work pretty well. But yeah, so in general, while there's a lot of good advice on the internet about reverse engineering with debuggers and things like that, I recommend you looking into that. Always keep in mind to never ever do that stuff on a live system, because you could run that binary by mistake, and then you're really going to be hating life because you don't know what it's going to do. Okay, so I spoke really fast, but I want to leave plenty of time for questions here. But just to kind of review everything and where we've been, to focus on the simple first, always remember that it's not always so dire, right? We get in this situation a little bit pessimistic about, oh, there's so many ways our network can get broken into, we have no way to defend ourselves. But you always need to remember as a white hat, once they get in, they're in our territory, and they're gonna make a mistake. And a lot of these things that I showed you in the slide today, you know, you might think this is simple or can't possibly work and on and on. And I'm telling you, if you look for these simple things, you're gonna be able to find a lot of people who are on your systems that you thought that they'd be a lot stealthier than they actually are. Again, the kind of the three things, suspicious directories, files, and processes, are almost always gonna be one of those three categories. You're gonna find something on these boxes that these guys have tried to do. And again, simple tools and careful attention is going to get the job done. Okay, so I can go to questions now, back and forth if you have questions on anything in particular. Yes?
So, Paul called me out earlier. I'm a policy person, so I'm a non-technical person you're talking to. But I wonder if there's anything like a white hat test lab that you can spin up and have play with these tools and have something that looks like a typical suspicious process to get a feel for these things.
Yeah, so his question is for the video, whether or not there could be some type of white hat club where you could spin up suspicious activity and have people go look for it. You know, there probably are. I mean, there are online pen test academies and stuff like that where you could test breaking into things. Usually what I'm doing is I'm setting up hosts at DigitalOcean and just turn into total punching bags, right? I mean, don't get banned, right? Don't get banned by these guys. But, you know, if you have the ability to look at the code ahead of time to make sure it's not doing something really bad, like setting up a botnet or DDoS or something, you know, don't run that stuff. But what I usually would do, I will have a target of saying, well, what is this one rootkit doing? What is this one doing? And there are other utilities inside of Linux where you can actually track. You can enable, I think, iNotify or some other ones. I need to look into them again. But you can actually see what is this process, what files is this thing touching as it's running on the host. So there are ways to do it. I don't think there's a formal lab. I think it's going to have to be something more like you sit down and do it. There could be a lab, I don't know, I haven't looked. But generally my approach is I'm going to look at the source code and run it myself and see what's going on. You know, and that's what I did. Over the past year when the equation group leaks were happening and all this other stuff going on, man, I just downloaded the source code and I just looked at what these guys did. And that's really an easy way to do things without even having to run any of their code at all. And that's kind of where I started noticing just how the common techniques can even spot these elite level hackers. Yeah, sure, they had cool stuff. They had like true zero-day type stuff that could work on a lot of systems. But if you look at the operational aspect of once they get onto the system, that's where you say it's all these very common things that can get spotted. You know, they'd have things in there. I remember they were using, on one particular attack, they were using like an .x11 file under temp to mark that they were there, blah, 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 blah. Well, a lot of systems don't load x11, right? It's things like that. It's just like, you know, why do I have certain programs showing like, oh, they're loaded on the system where clearly I don't run these types of things. But, you know, so even you see these elite level attackers, they're going to be doing common stuff. So I would say just go out, look at the rootkits, and maybe just find some DigitalOcean boxes. $5 a month, man, you can't go wrong. And just go out there and beat up on the things. Anyone else? Questions? Yes?
So you've talked a lot about systems that are already compromised or honeypot systems of that nature. Are there some really dumb things that people often do that lead to those situations? As in, you're looking at the already compromised system, but what's a common theme that's led to that situation?
Okay, so his question is, paraphrasing, is we're looking at compromised systems, but what are the common things people are doing to get compromised? Okay. Oh man, that's why we have this conference, right? I mean, that's why there's a 0% unemployment rate in information security, right? It's an endless stream of the same stuff over and over and over again. So I usually don't even focus so much on what vulnerability got someone onto a host. And the reason I don't is I don't know if I really care in terms of, it changes so much, right? So to answer your question, I don't think there's one specific thing, you know. But I could talk about some trends that we see today. So, for instance, you're starting to see, I think, a lot more use of encryption with some of these tools being built in. So, a lot of network-based intrusion detection systems are becoming blind, Even though some of them may say, oh, you could load a certificate and we're gonna do a man-in-the-middle inspection and stuff, you might get people who are tunneling encryption inside the encryption and things like that. So gonna think you start seeing more of that going on. Stolen credentials are always a big thing, and it's one of these things too where some of the attackers can try to get like almost too tricky trying to hide, and they make the situation for themselves much worse. Like some of these stealth rootkits, they'll do things that make it very, very obvious there's a problem once you see what's going on. Like something's just a little off, and then you're like, oh cow, yeah, this was not an accident, right? Someone did this on purpose. Now as to how they got in, I don't know. I guess my whole point of this presentation is just be on the lookout for it, because once they get on that box, you're probably going to be able to find them a lot faster. You might not know how they got in initially, but at least you could start looking to see how they got into the system. Yes, sir.
Is there a tool that will automate those data tests so you can run something that
What a coincidence. Yeah, I mean, the product I'm working on does a lot of things that help with this. It's a threat hunter. So it looks for signs of compromise post-fact. There are some older tools out there, check Rootkit, Rootkit Hunter, but that they might not catch a lot of different things like this. They're pretty particular. There's nothing overtly like it right now, but it's something that obviously I've had a burning interest in. So the past year or so, I've been looking into a lot of this stuff. So yeah, you can do it in an automated way. And again, I'm not here for a product plug because I haven't really announced my product yet, but you can go check that out. There might be some other intrusion detection tools that are out there that might fill a similar gap, but I'm not quite sure how capable they are or aren't, or how far they're going to take the feature set. Anyone else? Yes, sir.
Yeah, any comments on using SE Linux policies to prevent some of those real basic ones, like
Yeah.
SE block?
Yeah, the comment was, can you use SE Linux, and I assume AppArmor, stuff like that, maybe to limit some of this. Yeah, sure, but how many people disable SE Linux is one of the first things they do on CentOS. Yeah, it's a problem. I wish they wouldn't, but they do. So I think SE Linux could prevent a lot of this stuff, obviously, because you have that extra level of checks in terms of user roles and group roles and things like that, but unfortunately a lot of people disable those things. So, if they didn't, then a lot of this stuff wouldn't work. Yes, sir.
So you found some suspicious activity. What do you do next? Do you just delete the file, the image?
At bare minimum, you're taking the system down and re-imaging it. That's the minimum. It depends on what your policy is at your corporation. You might have certain forensics requirements that your industry requires. You're obviously going to want to try to figure out how they got on the box so it doesn't get repeated. So I wouldn't necessarily say blow the system away immediately, but you probably want to take it off the network and then get some offline forensic tools to get in there. Maybe you're going to want to image the RAM, image the disk, try to find out how they got onto the system. And this is one of the problems you run into a lot with the vendors and patches and things like that. Red Hat, these companies, they can only patch what they know about. And unfortunately, as soon as you load that system, you're going to put all your custom software on it. And at that point, they can't really do much. They can't really tell you how they got on. You might not really know. There could be, obviously there could be a hole in a commonly available package, but a lot of times, I think what you might find is it could be custom web apps, things like that. Developers make errors. SSH keys are stolen, stuff like that. That's going to get someone on the box. So, getting back to your question, what would I do personally? I'd probably want to take that system offline, do a forensic analysis, and find out how they got onto the system, just to make sure they didn't go anywhere else and cause a similar trouble. Okay, anyone else? No? Okay, I'll post this presentation online on my website as well if you want to grab it later. And obviously, again, I'll be around all weekend. Thank you and enjoy the show. Appreciate it.